Hey guys, this is section P3. It's entitled Linear Equations and Inequalities. I'm not going to give you all the vocabulary like an equation is a statement of equality, because I'm pretty sure you know what an equation is. It's important to understand that a linear equation, and you know that if you put that on a graph it would be a line. That's why we say a linear equation in one variable, because a linear equation in two variables would be y equals mx plus b, because the x and the y are two variables. We're just talking about one variable linear equations like x plus 3 equals 5. And the way we define, so then x would equal 2. The way we define a linear equation is any equation that can be written as ax plus b equals 0, where a and b are real numbers. Basically, any equation that has an x to the first power is going to be a linear equation. And we solve linear equations just like you've always done. You get the x on one side and all the numbers on the other. I'm going to do a whole bunch of examples because that's really the only notes for linear equations. To confirm something is a solution of a linear equation, you just plug it in. So like, is negative 2 a solution of 2x minus 4 equals 6? Well, hopefully you know that when it's x to the first power, there's only one solution. And you've probably already figured out that x is 5, because you add 4 divided by 2. But in order to check to see if it's a solution, you plug negative 2 in for x and see what happens. So 2 times negative 2 is negative 4, and negative 4 minus 4 is negative 8. So that does not equal, so no, it is not a solution. And you could do that for any type of equation. It doesn't have to be linear. I could make this x squared, x cubed. You would always just plug the negative 2 in and see if it works, and that's how you tell if something is a solution. We're also going to talk about linear inequalities. And a linear inequality just means there are infinitely many solutions, and they can be written in the form ax plus b is less than 0, or ax plus b is less than or equal to 0, and these could also be greater than 0 or greater than or equal to 0. Basically, again, if it's x to the first power and it's less than or equal to, it's a linear inequality. Now, there are infinitely many solutions to a linear inequality. Let me explain. If I gave you the equation again, 2x minus 4 equals 6, you know that x equals 5 because you add 4, divide by 2, x equals 5. There's only one possible solution. But if I say that 2x minus 4 is greater than or equal to 6, then when you add 4, you end up with 2x is greater than or equal to 10, and then you divide by 2 and x is greater than or equal to 5. That means any number bigger than 5 will make this statement true. Let's try it. Try 100. 2 times 100, 200, minus 4, 196. That is bigger than or equal to 6. And some people say, well, it's not equal to. Right, that's why the word or comes in. It's either greater than or it's equal to. And that's how an inequality works. Now, inequalities are a little bit tricky because you might have to do the trick, and people always forget this. So let me just say negative x plus 3 is less than 5. So negative x is less than 2, because I'm going to minus 3 from both sides. And so most of you would say, okay, divide by negative 1 and x is less than negative 2. Now the problem is, go to check this. Pick a number less than negative 2. How about like negative 5? If I say x is negative 5, and I plug that in, and I put in negative 5 for x, then it looks like this. Negative 5 plus 3 is less than 5. But what's negative 5? Positive 5. And positive 5 plus 3 is not less than 5. So it doesn't work when you just divide by negative 1. When you divide by a negative coefficient, I'm going to say that again. when the number in front of x is negative, this symbol has to flip over in order for the inequality to be true. So when you divide by a negative number, you flip the sign. Now, if I pick a number greater than negative 2, like 0, negative 0 plus 3 is 3, which is less than 5. So that makes it true. I'm going to write that down. When the coefficient of x is negative in the last step of the problem, flip the sign. Let's do an example. 5x plus 4 is less than or equal to 7x minus 6. Now most of you are going to go minus 7x because you like to have your x's on the left, which is fine. And then you're going to minus 4. You're going to have 2x is less than or equal to negative 10. Divide by negative 2. And x, now remember, the coefficient of x was negative. You have to flip the sign over. Greater than or equal to positive 5. Notice what would happen if you had moved the 5x at the beginning. What would happen if you had moved the 5x? Remember, the answer is greater than or equal to 5. I want to show you that you get the same answer, greater than or equal to 5. So if I minus 5x from both sides, now I have 4 is less than or equal to 2x minus 6, add 6. 10 is less than or equal to 2x, divide by 2. And 5 is less than or equal to x, which if we write that with the x on the left, if it's eating the x this way, it has to eat the x when you write it on the other side. So you still get the same answer. All right, let's get to some harder stuff. You're probably bored. Solving a double inequality. So for instance, negative 3 is less than or equal to 2x plus 5 divided by 3 is less than or equal to 5. So that means this expression, when we pick a value for x, has to be between negative 3 and 5 on a number line. Go ahead and solve this, see what happens. Pause the video and solve it. Welcome back. So, in order to solve this, we want to multiply through by 3. So I'm going to multiply this by 3 and this by 3. So I get negative 9 is less than or equal to 2x plus 5 is less than or equal to 15. Now I'm going to subtract 5 from both sides. And you get negative 14 is less than or equal to 2x is less than or equal to 10. Divide everything by 2. Now it's not a negative 2, so I don't have to flip any signs. Negative 7 is less than or equal to x is less than or equal to 5. So your answer, if you had to graph it, would be, look like that. Or in interval notation, it would be negative 7 to 5 with brackets. So basically what you're saying is you have two separate inequalities. You have an inequality on the left and you have an inequality on the right, and you're solving them simultaneously. So I'm really saying 2x plus 5 divided by 3 is greater than or equal to negative 3, and then I solve that. And then I say 2x plus 5 divided by 3 is less than or equal to 5, and then I solve that. I just did it in one step instead of two separate inequalities. Same answer, you get the same thing. Let's talk about whether or not something is linear. Remember, we said it has to be x to the first power. So 2 minus x squared equals 5, not linear. X plus 4 equals x minus 2. That is actually not linear, because when you try to put it in the form ax plus b equals 0, when you get everything on one side, you end up with 0 plus 4 equals -2, which is not a true statement. So this is actually not linear, and there is no solution to it. So the rule is, for ax plus b, a and b have to be real numbers, and a cannot be 0. So when you simplify it, a cannot be 0. What else do we have to do here? We have to talk a little bit about fractions. I noticed you guys were having a little bit of trouble with fractions. So let's try a problem here. What do I want to do? Oh, that's a good one. 3 minus 4y over 6 minus 2y minus 3 over 8 is greater than or equal to 2 minus y. See what you can do for this. You try it. Pause the video and try it. Okay, welcome back. So, the common denominator between 6 and 8, hopefully you thought was 24. You could have used 48. If you ever have trouble finding a common denominator, you can always just multiply these two numbers. And then you'll have to reduce at the end. But the common denominator between 6 and 8 is 24. So I'm going to have to multiply. Some teachers teach to multiply through everything by 24. That's fine. I prefer to write everything over 24 and then just get rid of the denominator at the end. I think it's easier to see it that way. So for instance, this fraction, if I'm going to put it over 24, I have to multiply by 4 on the top, because I had to multiply by 4 on the bottom. So 4 times 3 minus 4y. And then here I have to multiply by 3 on the top, because I multiplied by 3 on the bottom. And then here I have to multiply by 24, because I had to multiply by 24 on the bottom. But now that the bottoms are all the same, I can get rid of them. Because once your denominators are the same, the tops must be the same. So I can get rid of my denominators now that they're all the same. And I simply have this linear inequality. So I'm going to distribute. 4 times 3 is 12. Minus 16y. Minus 6y. This is a minus sign, I think. Plus 9. This one's tricky because it's a -3 times -3. So it's plus 9 is greater than or equal to 48 minus 24y. If I combine like terms on the left, I'm going to go up to the top here so I have room. Combine like terms on the left, I will get 12 plus 9 is 21, and -16 minus 6y is -22y is greater than or equal to 48 minus 24y. Now I've said before I like my variables to have positive coefficients, so I'm going to move my 24y over here. I'm going to add 24y. I always move the smaller one, and -24 is smaller than -22. So again, I'm going to give myself some more room. Okay, so 21 plus 2y is greater than or equal to 48. Now we're going to minus 21. So 2y is greater than or equal to 27. And divide by 2. Y is greater than or equal to 13.5. Okay, and if you had to write that in interval notation, you would say bracket 13.5, comma, infinity. Remember, infinity and negative infinity always have a parenthesis because you can never actually equal infinity. And sometimes you have to draw a number line, so obviously you know how to do that. 13.5 bracket greater than. Okay, so you need common denominators when you add and subtract fractions. I think I'm done. I think that's pretty much everything we're going to talk about in class. We're going to practice a lot. And then we are going to take a quiz on P1 through P3 probably on Thursday. So plan on that, quiz on Thursday. Okay, hopefully you watched all the notes so you know when the quiz is. Talk to you later. Bye. Ha! I just acted like this was a phone call. Nope, just a little video.